Hello guys, welcome to today's chemistry class at Scholarly Educate. So today we're talking about compound mixtures and separating techniques. We all know that elements can be classified based on their uses such as metals, non-metals or metalloids, and also on their degree of reactivity. Example of elements include hydrogen, sodium, calcium, and argon. We know that compound comprises of two or more elements chemically combined together, and we can classify them based on their behavior when exposed to the atmosphere. Compound which loses all or parts of their water of crystallization are called efflorescents. Example is sodium trisulcarbonate 4 decahydrate and copper sulfate salts. As you can see, we have the blue hydrated copper sulfate and we have the white or dry anhydrous copper sulfate. These are fluorescent salts. We also have compound which absorbs so much water from the atmosphere to the extent that it turns into the solution of the compound, and we are called deliquescents. Example is sodium hydroxide pellets and also iron trichloride. Compounds that absorb water from the atmosphere which become moist but not to the extent that they form solution are called hygroscopic compound. Now you have to note that not all deliquescents are hygroscopic, but all hygroscopic are deliquescents. Example of hygroscopic compound include salt, silica gel beads, and others. Let's talk about desiccants. Desiccants are drying agents that are either deliquescents or hygroscopic compounds, which are used to dry substance in the lab. Examples include concentrated tetrasulfate 6 acid for drying acidic gases and quicklime or calcium oxide for drying alkaline gases. As you can see, the desiccant is placed under the wet substance. Now we know that mixtures are impure substance. Mixture can be on the same phase like a mixture of sugar and water, which is a homogeneous mixture, or a mixture of a different phase like a mixture of oil and water, which is a heterogeneous mixture. Now, heterogeneous mixture is actually based on the particle size below when you want to classify them. We have colloids, we have suspension, we have true solution. You can pause the video to see some of their properties in terms of their particle size, their visibility. Do they scatter light ray? Do they exhibit the tidal effects? Do they have Brownian motion? Do they separate on with cut in contact with a porous materials like filter paper? And you can pause the video to look at the properties. Now, when we talk about colloids, we're talking about the dispense material and the dispension medium. The dispense material is akin to the solute in the solution, while the dispension medium is akin to the solvent in the solution. You can pause the video to go through the different dispense material and different dispension medium in gas, liquid, and solid. Let's talk about separating techniques. The principle of separation is based on the fact that substances have different physical properties. Their boiling point, their melting point, their solubility, their specific gravity. Decantation is the separating techniques of separating immiscible substance due to their difference in intensity. Example is separation of a mixture of sand and water, whereby we decant the less soluble material. We have filtration. Filtration is used for separating mixtures of solid in a liquid through a porous medium. See in the picture above, we have the filter paper in the funnel and we have the residue, which is the solid material, and we have the filtrate in which we have collected. We also have another separating technique which is called evaporation. It is used in the separating of solutions that have solute and solvent in which one will turn to vapor upon the addition of heat. Let's take for example salt and water. The water will evaporate, leaving the salt behind under the addition of heat. We use our evaporating dish to carry out evaporation. We also have another separating technique which is called distillation, which can be simple distillation or fractional distillation. Simple distillation is used in separating mixtures of solvents with different boiling points, about 1 to 10 degrees Celsius different. Example is the separation of a mixture of water and alcohol. Water boils at 100 degrees Celsius, alcohol boils at 78 degrees Celsius. So alcohol will distillate first, passing through the condenser and collected as the first distillate before water. We have fractional distillation, which undergoes the same techniques except with the introduction of a fractionating column, which is packed with beads, silica beads to be precise. It is used in separating fractions of a substance of closely related boiling point. Example is the separation of crude oil. We also have magnetization, use of magnet to separate a mixture of magnetic substance from non-magnetic ones. Example is a mixture of iron and sulfur powder. The ion is magnetic to attract to the magnet, separating it from the sulfur powder. We have extraction and separating funnel. Extraction depends on the principle that a solvent can extract a constituent in a mixture if it is soluble in that mixture, while separating funnel is just based on the different density of two immiscible liquid, like we have an organic solvent and water, oil and water, crude oil and water. We have centrifugation. Centrifugation is another separating technique which is based on the difference in densities of constituents in a mixture. Let's take, for example, the centrifugation of blood. We have the blood cells being at the denser parts, being at the lower part, and we have the white blood cells and blood plasma being at the top. We have crystallization. This is a separating techniques that is used to separate salts that can be easily decomposed on heating. You can see in the picture above, you can pause the video, and we can see that we have to induce a seed, which is the salt, or scratch the inner surface of the evaporating dish to induce crystallization. Chromatography, which is based on two phases, the mobile phase and the stationary phase. The mobile phase comprises of the solvents and the mixture to be separated, while the stationary phase comprises on the medium in which the separation is carried out on. You can pause the video and read the picture above. Chromatography is based on the different rate at which different constituents in a mixture will be absorbed on an adsorbent material, and also the rate at which they migrate, traveling throughout the material. Chromatography is used to separate pigments of mixtures like drugs, inks, and dyes.